Okay, so make sure that you have your name at the top. I will be checking this at the end of class to give you credit for it. So put your name here, your name. Date is the 7th, so 12/7/20, and class period, 3rd period. Put that at the top there. Okay, so we did spend a couple, it's like 1 or 2 lessons that we focused on parallel and perpendicular lines. Now we're going to review it, just make sure it's fresh in our head. Parallel as a concept, pretty easy. It's literally parallel lines. Parallel lines are straight. They go on and on forever and ever and never intersect. I'll put this underneath a stack of paper so it's clear. That's what parallel lines look like. Parallel lines in the equations have the same slope. And what that looks like in terms of an equation is like this. Y equals 2x plus 6, and maybe y equals 2x plus 2. So if you're given these two equations and you were asked, are they parallel, perpendicular, or something else, you would look at the slopes, you see that they have the same slopes, and you could say that they are parallel. If you weren't sure about the rules, you could graph it out. So just draw a coordinate plane. Oh, there's what I drew. Okay, and now I'm going to graph these two equations on the coordinate plane. So for the first equation, the y-intercept is 6, so I'll put a point at 6 on the y-axis. 2, 3, 4. So there's my point there. The first equation, the slope is 2, so that means we go up 2 over 1. And then you can graph that line. For the second equation, the y-intercept is 2, so a dot on 2 on the y-axis. And the slope is 2, so we go up 2 over 1. Oh, well, there's some human error there, but they are parallel. So then you have parallel lines. Okay, and then perpendicular, as you may remember, is just when you have two intersecting lines that form a 90-degree angle when they intersect. And the slopes of perpendicular lines are negative reciprocals. So slopes are negative reciprocals, and however you need to squeeze that in there. So for example, if you have a slope of 1/2, a line perpendicular to it would have a slope of negative 2 over 1. So you flip the fraction and make it negative, or if your original number is negative, you make it positive. Obviously, you wouldn't write this as negative 2 over 1, you just write it as negative 2. So with two equations that are perpendicular, it would look like this. Y equals 2x plus 2, and maybe y equals negative 1/2 x plus 3. Okay, so before we even graph it, we can just look at the slopes and see that they're going to be perpendicular. Their slopes are negative reciprocals. 2 over 1 would flip to 1 over 2, and it becomes negative. If you were looking at it in a graph, use the rest of this here to graph it. And And again, if you forget the rules or anything, you could always just graph it and see if they're perpendicular or parallel or whatnot. The first equation, y-intercept is 2, and then the slope is 2, so we go up 2 over 1. First line. And then for the second equation, the y-intercept is 3. So I put a dot on 3 on the y-axis, and then the slope is negative 1/2. So that's down 1 over 2. And looks perpendicular to me. It creates a 90-degree angle when it intersects. Okay, so on the exam review, it says that you'll either have to identify them as parallel, perpendicular, or neither one. These are the other two scenarios that could happen that would be under the neither category. One would just be intersecting. Intersecting lines would just cross, and then they don't have any specific angle that they make. Could be anything. With intersecting lines, the slopes have no pattern or correlation. So for example, let's say the equation is y equals 2x plus 8 and y equals 4x plus 6. In this case, the slopes aren't the same. They're not negative reciprocals. We're looking for these two scenarios. It doesn't have either of those, so these are just intersecting lines. Another situation that may look a little bit trickier and may make you second guess yourself, but they're just trying to trick you or making sure that you really know the rule, would be if they give you two equations like this. Y equals negative 2/3 x plus 2. Y equals negative 3/2 x plus 4. So let's say they give you these two equations. You look at the slope, you notice that they are reciprocals, they flip the fraction. However, they're both negative. If they were perpendicular, one should be positive, and it's not. So therefore, this is kind of a trick question. They're just intersecting as well. And the last scenario would be same line. This comes up in the Khan Academy questions as well, where your equations are just the same equation. If it's the exact same equation, same slope, and same y-intercept, it is the same line. It's not always as obvious as it seems, though. For example, they'll give you two equations. One will be y equals 2x plus 4. And then the second equation will look like this. Y minus 4 equals 2x. And so you look at it, you're looking for the slope, it just can't line it all up. But if you change this into y-intercept form by adding 4 to both sides, you notice that this equation and this equation is the exact same thing. It would graph the exact same line. Okay, so that's the concept overview. Now we're going to look at the exam review questions that the district gave us to practice. Did you get it all? Okay, so number 1, it says, are these equations parallel, perpendicular, or neither? And there's actually 3 separate problems here. So starting with A, they gave us 2 equations. However, only one of them is in slope-intercept form where I can really look at the slope and compare it to the other one. So I need to rearrange this so that it is in slope-intercept form so I can compare them. So for this, I'm going to subtract 8x from both sides to get it to the other side. Then divide by 4. y equals negative 2x minus 2. So there's my equation here. And I'm comparing it to this equation. I noticed that the slopes are the same. I just need to make sure my y-intercepts are different, and they are. So therefore, these two lines are parallel. And they have the same slope. For B, the next one. The next one, you actually don't have to rearrange the equations. They're both in y-intercept form, or slope-intercept form. I look at the slopes. They flip the fraction and make it negative, so that means the slopes are negative reciprocals. And that means that these two lines are perpendicular. Okay. The next one, we have two equations here. They both aren't in y-intercept form, so we can't compare the slopes in that format. So we need to rearrange both of them, so that way it's just y equals, and then we can look at the slope. So I'm going to subtract 5x from both sides here. 5y equals negative 5x. Divide by 5. Y equals negative x. And then over on this one, same thing. Need to get y by itself. Okay, so these are the two equations that I'm comparing. I want to look at the slope to see if there's any correlation there. Is it the same slope? Is it a negative reciprocal? And neither. So in this case, these are just intersecting lines. And the answer to their question, are these equations parallel, perpendicular, or neither? The answer is neither. And then we're going to move on to the other side of the page. Okay. Still a couple people finishing up. Okay, so we're just going to move over to the other side. Continue just kind of squeezing it in, this space. Again, I'm using a larger template so that way my handwriting's clear. So here's another type of question they gave me on the exam review that they might ask. It says, describe the relationship between, and then we have 4 problems here, A, B, C, and D. So we're going to start with A. Describe the relationship between lines A, B, and line C, D. And they gave us 4 coordinates. Now, they aren't going to give you the coordinate plane to work with. You'd have to draw that out on the scratch paper and then plot the points. So here we go. Point A is at negative 4, 7. B is at 2, 1. So there's AB. C is at negative 2, 2. And D is at 1, 5. Connect the dots. Okay. Okay, so describe the relationship between. It is definitely not parallel. It's either perpendicular or intersecting. I would bank on it being perpendicular because it does look like it forms a 90-degree angle. If you wanted to be completely sure, then you'd have to find these slopes, which isn't really a big deal. So slope of AB, line AB. So for this line right here, to find the slope, you go down and over. So we're going down 6 over 6 if you were to count each square. So it would be negative 6 over 6, which equals negative 1. So your slope is negative 1. And then the slope of CD goes up 3 over 3. So 3 over 3 equals positive 1. So you're looking at, are these slopes, are they negative reciprocals? Well, negative 1 over 1 flipped would be positive 1 over 1 as a negative reciprocal. So yes, they are perpendicular. Okay, next type of question, B. These are always tricky, but they're easy if you know what they're looking for. So it says the equation of the first one is y equals 3 and then y equals negative 4. Remember, you have your x and your y axis. To plot this line y equals 3, you just put a point on y equals 3. And if y is forever equal to 3, then your line looks like this. It's just a horizontal line where y always equals 3. Then for y equals negative 4, 1, 2, 3, 4, right here. Y always equals negative 4. Again, a horizontal line. The relationship between them, they are parallel. Okay, number C, I didn't leave room to graph it because you don't need to graph this one. C, it says that the slope is 2 and the slope over here is negative 1/2. That is a negative reciprocal of this slope, so these are perpendicular. Negative reciprocal slope, so they are perpendicular. D, again, it's important to recognize that this is your x and this is your y-axis. That'll help you avoid errors with this. X equals 5. So 1, 2, 3, 4, 5. And if x always equals 5, it is a vertical line. And then it says y equals negative 2. So we plot negative 2 on the y-axis. And this is a horizontal line. Well, if that's not perpendicular, I don't know what is. That is perpendicular. Okay, 3 and 4 are the last type of problem that you could see on this. 3 says, find the equation of a line in slope-intercept form that passes through negative 2, 6 and is parallel to this equation. The way to do these is to use point-slope form, which is y minus y1 equals m times x minus x1. This you do have to memorize. It is not on the reference sheet. You have to have it memorized. How do you use this formula? Well, these points x and y, we're going to plug into x1 and y1. And then if it's parallel to this equation, then the slope has to be 3, and we're going to plug that in for m. So that's how I'm going to do this. Y minus the y coordinate is 6. Slope is 3. x minus the x-coordinate -2. It wants the formula in slope-intercept form, so we do have to rearrange it so it's y equals mx plus b. So I'm going to simplify this. 3 times x is 3x. Subtracting a negative is just +2, so 3 times 2 is 6. And then add 6 to both sides to get y equals 3x plus 12. And that's the answer. And last one, find the equation of a line in point-slope form this time that passes through these points, or this point, and is perpendicular to this line. Well, a slope that is perpendicular to 1/2 would be -2, so that's what we're going to use. Point-slope form, that is this format, so I'm just going to plug the coordinates here and the slope into this format. Y minus 2 equals -2. X is 0. Wait, x minus 0. Then from here, you might simplify it a little bit if you can. But it does want it in point-slope form. So once we're here, we're technically done. The answer key said it could be either one of these as a correct answer. The exam is multiple choice or multi-select, though, just to keep that in mind. Yes, Autumn?
Wouldn't you do y equals -2x plus 2 because you want it to be in slope form?
Well, this says point-slope form, so that's why I didn't go that far. So that's that. Okay, so you will have the rest of class to work on some of your assignments. Just so you know, the exam review homework number 1, it doesn't review this parallel and perpendicular line stuff. This is made by the district, and it's only on the non-calculator portion of the test, which we're going to be working on tomorrow. So take this as kind of like a preview or a little review of what we're going to be focusing on tomorrow. You will recognize all the content. We've seen it all. If you have questions, of course, let me know. Also, you're going to need to start working on Khan Academy tonight. I would recommend focusing on the parallel and perpendicular line questions since it is fresh in your head and it'll help like kind of solidify it in your brain. And then study these notes that we just wrote. Studying means you could look it over, you could watch the video that will be posted and just kind of like watch me work them through and explain it again. You could also print this out, so I'll have this template online, so if you want to print it out and work through the problems again, you can do that as well. So you will have homework tonight, you won't be able to finish this all in the 20 minutes. Use it as study time, so just don't try to click things to get it right. Try to understand each question that you're doing, that way when you see it on the exam, it'll be easy at that point. Okay, so you can get up, get a laptop, get started.